Alright, we're on the air. Good morning, actually, or whatever time it is in your place. My name is Bernardus, and before we start anything today, I want to stay. I want to say Happy Easter for those of you who celebrates it. I don't know what to say, but yeah, that's what I want to say. Happy Easter for those who celebrates it, me included. So yeah, I don't know what to say. So let's get started immediately. As usual, this is my kitab issues. Kitab issue. You can see what I did throughout the week. I only did two because this week was very busy. So I also moved my Obsidian from a Windows software into my Windows subsystem for Linux. So yeah, it looks a bit different now. But without further ado, let's get started on this week's material, exception and error in Java. Shalom. Yes, as I said, this week has been very busy for me. And yes, I did the first one before Monday, Thursday Mass. So it's not kind of rust, but you can see why. So, let's get started. The first section on day 1, the throwable family tree. No integer, just object. So in C, when you get a success, you get the number integer 0. You return or get 0. But in Java, errors are not integer. They are object. And the throwable family tree consists of 2 members, error and exception. So you need to know the distinction between the two. Error in Java means that your computer is on fire. No joke. There is no error as in C segfault, error out of bounds, etc. Error in Java means your computer or JVM is on fire. Out of memory error, stack overflow error are unrecoverable errors. Do not catch this. And as an analogy, why would you fix a car whose machine already exploded instead of buying a new car? That's the closest analogy I can get, because errors in Java are unrecoverable. It basically means that your whole computer or Java virtual machine is on fire, as you can see. So that if error is unrecoverable, exception is the exception. So now this isn't the Java virtual machine's fault. These are the things that happen inside the code, and there are 2 types of exception. The first one is checked exception. This is the exception that the compiler forces you to handle and doesn't necessarily mean your JVM is on fire. But these are errors that are checked at compile time, forcing the programmer to handle them. So basically, something like database connection, which can sometimes fail, disconnect, reading file, which can sometimes not exist on the hard drive. The Java language forces you to check them. It forces you to put them inside a try check block because it is quote unquote checked exception. As you can see, I tried reading a file, but I didn't put it in any error catch block. So yeah, unreported exception, file not found exception must be caught or declared to be thrown. Yep. Input output exception and unreported input output exception. We got 3 errors. The reason that this throws an error is that the compiler checks the file and the content. If the file doesn't exist, which is expected in the real world, the file won't even compile, and you need to surround this in try catch block, which will be explained later. So it's basically the Java forces you to create a plan B, so you can be prepared for any edge cases or unwanted scenarios. Yes. The next one is unchecked exception. As the name suggests, it doesn't get checked during compile time. Instead, it is mostly a runtime error. This is the most important part. This is not an error. An exception is Java gracefully crashing your program to avoid undefined behavior or segfault. Not always gracefully crashing, but if you surround this in a try-catch block, instead of crashing when the CPU detected a 6F, null reference, the catch block will be executed later. How? Explain later. Yes. So this is an example of it. I have an array of 4 and I tried accessing the 6th array. Instead of Java letting me access the memory 8 bytes away from the array, the Java just out of bound. Array index out of bounds exception. Pretty verbose. So this one is also another unchecked exception. This is a Java long null pointer exception because the reference, it doesn't point to anything. It points to the address 0, OX0, which, as we learned in our memory issue, is that the 0 is used by the operating system for detecting error. There are still more examples as like arithmetic exception and illegal argument exception and many more. And yes, their name are this long. They are very verbose. That's Java for ya. So next section. This is what I talked about. This is the try-catch block. There's a reason why I called it a nested hell. Because it is actually a nice feature to catch exceptions. But there is a catch. Okay, there is a catch inside the catch. Got it? But okay, every checked exception must be covered inside a try-catch block. Remember it. This is important. Every checked exception. From our earlier example, this one, it will throw input-output exception and file not found exception. Because Java will have no way how to handle this command if the file isn't found. So Java throws an exception object. To fix that, we have to add a try-catch block. Now this is basically getting the directory of the current file. So we are reading from the current Java file. This is what we are reading. We add the name of the file, and then we print line the file path and then put it outside so we can access it inside the try-catch finally block. We do file reader. We print each 3 lines inside the counter, and if there is no file or the buffer reader doesn't work, exception will occur. And then finally, now you need to remember something. Garbage collector manages memory management. But JVM doesn't handle file descriptor management. So we need to close the file descriptor unless you want a file descriptor leak. Now, if you copy paste this code into an IDE like IntelliJ IDEA, which I won't do this time. I'm sorry. Next week I'll get back into the IntelliJ IDEA, but this week, yeah. If you copy paste this code into IntelliJ IDEA or VS Code or any Java text editor, you will get input-output exception. Remember what I said earlier. Every checked exception must be inside a try-catch block. And wanna guess? Look at the finally block. Look at that one. We do buffer reader.close and file reader.close, even though it could be no from our earlier here. Yep, we covered the dangerous part in a try, but inside the finally block, it's naked. It's uncovered. So yeah, this is what I call by nested try. This is basically the same, but inside finally, you have another try catch. But if you're just lazy, just put the file reader and the closing inside the try. Yep, finally is optional, but it is what will run when try finishes or catches an error. What this I don't know if I'm correct or not, correct me if I'm wrong again. If this succeeds, let's say this succeeds, but then it crashes on this line, close will never be reached, so we'll get a file descriptor leak. That's why finally was needed. But as you can see, you need nested try just to close the file descriptor. And this led us to a Java feature, try with resources. Finally is finally redundant. So to avoid having a finally nested try, we use something called try with resources. It basically initialized and closed your file reader or anything that needs a try catch block. So inside the try, you put the declaration which you need to open when opening a file descriptor or anything, maybe socket or anything, inside a is this parenthesis? But yes, put it beside try. So when try fails or catch finishes, it will automatically call .close on this one, and it will print this one. Yes, I printed this because this is the placeholder I used. Yeah, basically. Yes, that is basically it. Automatically closes file descriptor, stream, socket, or any objects that implement Java lang auto-closable or its sub-interface closable. Will automatically run .close method when try finished or catch finished. So now we understand about error, exception, and how to manage them properly. Let's create our own. Creativity knows no bounds. Yes, what did I just write? But anyway, before we go deeper, we need to know one Java keyword, throw. This doesn't exist in C, but let's compare it to return. So return in C and Java just ends the current method, ends the current block immediately, and go to the immediate caller. So it's only one level up. But throw in Java, it will teleport to the nearest catch block. It can be many level up. So basically, how many jump it needs to reach the nearest catch block. So the requirement for return is that it must match the function or method's return type, and for throw, it must be an object that extends throwable. Throwable is what allows us to create our own exception. So cleanup. So cleanup must manually clean up before returning, otherwise in C you'll get memory leak if I'm not mistaken. And throw, the JVM automatically triggers finally block during the jump. And intent for return is expected result of a calculation. While throw, it is signal of an error. It is up the point of no return. So if you want to basically stop this method's execution immediately, go to the nearest catch block, use throw, because catch will catch it. What did I just write? Okay, so now custom exception. It depends on your need, unchecked or checked. For unchecked, which is a runtime exception, your exception must extend runtime exception. So I have this exception right here, which extends the runtime exception, and yeah, I can throw this when error. Okay. As for check, your object needs to extend exception, and it will be a check exception. This basically makes the programmer think about plan B. Both are used to prevent undefined behavior, but one is enforced at compile time so the programmer can make a plan B for user error, and the other is created so the programmer can know what happened when the program crashes or developer error. Yes, this is a check exception. So next we'll learn how to prevent errors inside the JVM. I will excuse myself for a bit. I want to drink. Okay, so the next day, the death of undefined behavior. Long live safety. Yeah, I've been very busy during the I got home 4 a.m. during the at Friday, and then slept for 10 hours. So yeah, I got many assignments left from my school. So after this, I will finish them. So let's get started on day 2. You first must know that JVM implementation depends on what type of the Java development kit you have. But mostly that which includes OpenJDK, JVM is written in C++, the language where it's famous for blowing your whole leg off. Wow. So now we know JVM is literally written in a language where segfault and undefined behavior are daily foods. So how can Java be safe? First of all, you must know that we as programmers, we as humans are inconsistent. Meanwhile, a machine cannot say maybe. It can only say 0 or 1, yes or no. Humans make mistakes, and that is our nature. Even I make mistakes. Human doesn't operate in 0 or 1. We are unpredictable and we make mistakes a lot. Machine, on the other hand, only understands 0 and 1. No maybe, no 0.5, no I am lazy so others will handle this. So once coded in place, the JVM will always act according to the code. It will free when garbage collection sweeps in, and it won't forget it. It won't double free. So next, JVM is... So after we learned that we know that machine is consistent, we need to know that JVM, in order to prevent undefined behavior and segfaults, is proactive, not reactive. So in JVM, you don't manually manage memory, which eliminates half of the cause of UB and segfault. But there are some cases where the JVM prevents UB. There is 2 prevention I found. Again, if you find any mistake, feel free to correct me. Because this is public learning, I'm not teaching anyone, and if you want to grow together, please help me as well, okay? It's a win-win condition. So, the first one is prevented by the language. Basically, most memory management related undefined behavior, which occurs when programmers need to do things manually, are prevented. Because there is no free, no malloc, and you don't manually manage memory yourself, dangling pointer, uninitialized pointer cannot physically happen. And there are some conditions that the programmers are unable to create unless it's the language / JVM itself that is broken, like buffer overflow. Yeah. However, there is a unique case for signed integer overflow, which wraps around the negative value. Sorry. So the next one is prevented by exception. Even though most of your manual memory management had been removed, there are still cases where undefined behavior can still happen, like a null pointer. Remember, Java references are a quote-unquote pointer to the heap. So this triggers an exception and gracefully crashes the program, or will execute your catch and finally block. As you can see, this is prevented by the exception. The same with out-of-bound array. Instead of letting a leak, the Java takes the index of an array and prevents it from happening. Remember, error equals your computer is on fire. Checked exception means you need to plan for user/runtime's error. Unchecked exception means you, as the programmer, are at fault. Me included. Okay, so next, how does JVM prevent error by using exception? So in C, an array out-of-bound index means you access your neighboring memory size. If you dereference an uninitialized or null pointer, sometimes maybe undefined behavior, sometimes maybe safe. But in Java, they don't allow that. After most of the cause of undefined behavior is eliminated by the language nature, most of the remaining undefined behavior cause, like array out of bounds and null pointer, are prevented by 2 types of failure handling. So, again, correct me if I'm wrong, but what I found is proactive handling and reactive handling. Proactive means it actively prevents the error in C from happening, and then reactive handling, which it is waiting for it to happen and then immediately react. So Java doesn't let you walk into someone else's house. It holds you back. Before each access of an array, the JVM checks, are you accessing an index that is bigger than array.length, and act accordingly. But that is not the loop case. If you do a loop, the JVM will see I will always be smaller than array.length. It skips the checks, making it supervised. And remember, Java is a just-in-time compiled language, so it can see your code and then compiles it into native machine code. When it sees that this is safe, let's compile it to machine code. JVM is smart and has been perfected over 31 years. Java is created in 1995. So the next and our last subsection is reactive handling. Now is the fun and nerdy stuffs. Remember system calls and remember memory management. If, let's say, I have a string, my string null, and try my string.length, would the JVM check on every access? No, that would be slow. Instead of memory management for whether it is accessing OXO or not, the JVM lets it be. It leaves this unsafe in the name of performance, but it's still safe. How? But there is a catch. When you access a virtual memory you don't own, the page fault is triggered, remember in memory, and the operating system sees you are asking for OXO instead of a seek kill signal. The operating system does something else. Because earlier, during Java virtual machine booting up, it calls the operating system via system call. It tells the kernel, hey, I know I just did a mistake. Don't shoot me with seek kill. Instead, jump to this specific address in my memory to run my own seppuku. So basically, it tells the kernel, if I ever do something that violates the memory, instead of killing me it directly, tell me what did I do wrong and let me handle it myself. So that's basically it. So that's how you get null pointer exception in Java. Even though you are accessing OXO, instead of being bogged down by the operating system, the process that lives on the third ring has its own way of handling errors, and that is called exception in Java. Pretty nice. Penguin approved. So yeah, that's basically it. That's basically what I learned throughout this week. This week has been very busy for me, so I didn't really have much time to learn, and this material is quite, how should I say it? There's not really that much to learn to begin with. So yeah, that's basically it. Once again, I want to say Happy Easter for everyone that is celebrating, me included again. So yeah, that's basically it for this week. I, Bernardus, signing out, and thank you for watching.